Hello and welcome to this repair tutorial, and today we're going to look at a Cambridge amplifier and the model number is A3i. In terms of general specifications, power output is 50 watts RMS into 2 times 8 ohm speakers. Frequency response is 2 Hz to 50 kHz and total harmonic distortion is 0.05% at 1 watt. And then for your inputs, CD is 400 millivolts, auxiliary, tuner and tape is 200 millivolts. And then you have a nice feature where you can select the moving magnet input, and this is 1.75 millivolts, or just select a standard line input. You have individual controls on the front for your bass, treble and balance. And then you have a 3-way rotary switch where you can select minus 20 dB attenuation for the gain. You can select normal mode, which means the tone controls are in circuit, and then direct mode will bypass the tone control. You can also mute the amplifier by pressing the push button on the front, and this will de-energize the internal speaker protection relay. Dimensions is 430 mm wide by 300 mm deep and 90 mm high, and the weight of the amplifier is 5.6 kilograms. This amplifier does not support any form of remote control, and it does not have a headphone socket for private listening. Now, if we look from the top, the first thing I'm highlighting here is the reactance core transformer. And the objective of this type of transformer is really to provide the minimal amount of electrical noise. So commonly in audio amplifiers, and I'll put a link in the description for the video, for a tutorial which I made previously which covered different types of transformer design and their use in audio amplifiers. So on low-cost amplifiers, it's very common to find an EI type transformer constructed from laminates. Then you will see a toroidal transformer which offers better electrical noise operation, and then here the R core or reactance core. But what we're tending to find now, many modern amplifiers are also implementing switch mode power supplies. Now in 1997 Cambridge Audio released this service bulletin, and what it's advising is that there was mechanical noise or a hum which could be heard from the R core transformer. And you can see that the advisory note is to actually swap around 2 wires on the secondary. So it's effectively switching the phases around to minimize that mechanical noise. If your amplifier is predating this service bulletin, you may want to look at that and make the change. And then here, if we look at the main amplifier circuit board, you can see that there's a high amount of dust, but this is very common. We'll imagine this amplifier probably never been serviced, but it's straightforward enough to clean all this out. It's not come from a damp environment. There's no liquid spillage or anything like that, so you'll just need a stiff brush and a compressed air line or maybe compressed air canister used for cleaning keyboards and computer equipment. 5 or 10 minutes later, you should be able to completely clear all of that dust out of there. It just accumulates through the vent grills on the top of the case. Now, what was the issue with this amplifier when it came into the workshop? Well, what the owner advised was that the amplifier was working, and I did confirm that during the initial power up and test. But what he'd done is he'd done some research online, and he looked at the forum site called DIY Audio. And on that forum site is information concerning modifications that can be made to the Cambridge A3i by the original designer of the amplifier. So what he provided was a number of things which he wanted to be modified, and the objective of that is twofold. The first one is it improves the reliability of the amplifier, and it will also improve the total harmonic distortion of the amplifier compared to when it was originally designed. And we carry out that work in the tutorial, and I'll step you through it. When you look here, what I've done is I've just removed the back cover, and on the left hand side you can see the input RCA connectors. There's a ground connection, which is the green wire, which then bolts through one of the fixing screws for the heatsink to the chassis. And then the left hand side, this is your circuit for your phono stroke line input stage, and there's also a multi-pin switch on there. And one of the asks from the customer was to replace the power cable as it was showing signs of age and wear. So here what I've done is I've just replaced it then with a brand new cable, so it's a 2-core with an integral moulded mains power plug. And it's straightforward enough. You can see that there's just some black cable ties just securing it through the main circuit board, and then it solders directly near to where you see the fuse carrier and the power switch. Now, one of the very common issues with the Cambridge A3i is dry solder joints. And what I would also note as well is that the circuit board tracks are quite thin. So this isn't the highest quality circuit board that you will come across in an audio amplifier. The reason why I mention that is just be very careful on how much heat you apply and for the time period that you apply it. When you are making modifications or you are repairing the amplifiers, it's very easy to find that some of these circuit board tracks will just lift away from the board. So if you can avoid that at all cost, it will benefit you in the end. If we take a more zoomed in view, what I've done here is I've circled just some examples of these dry solder joints. Now, as with all of these tutorials, you do need to undertake this work. It's not a case of doing the modifications or repairing one of these amplifiers and then get it to a condition where it's operating and then feel comfortable with that. You've got to put the longevity back into it. So here for the main amplifier circuit board, you need to check every single solder joint. And I'll guarantee probably 98% of those solder joints you will need to reflow. And as always, just be very careful to check your work, ensuring that you don't have any solder bridges. And then here what we're looking at is the two large power supply smoothing capacitors. One of the asks from the customer was to replace these because, of course, they've been in since the amplifier was released from the factory or manufactured. The other thing which was apparent was that when these two large smoothing capacitors were removed, you can see here that we have this brown glue, which really plagued amplifiers of this time era. It's not excessive and it's not coated any other components. So just use some, in my case, flux remover, which then just softens up the brown glue. And then I was able to just take a plastic scraping tool, wear some eye protection, and then just scrape that away from the circuit board and then just wipe it off. So it was completely clean. And then I was able to install the new power supply smoothing capacitors. The other area, and something else which needed to be replaced, is this device here. This square component which has Cambridge Audio written onto it is this speaker protection relay. The switching contacts inside are going to be oxidized, and the last thing that we want is maybe to carry out the modifications and replace the power supply smoothing capacitors, only for the amplifier to be returned back and there's some low-level distortion or intermittent loss of sound. So you can't open this relay up. It's a sealed unit, so we simply replace that with a 24-volt DC coil relay, and the switching contacts are double pole changeover. Now, the areas that we need to focus on for the modification are multiple, and what the designer is advising is, with regard to the power supply in the Cambridge A3i, is to replace the 4 rectification diodes that I'm pointing to here on the left-hand side. Now, what you find with silicon diodes is that they switch on at 0.6 of a volt, but they can generate some level of electrical noise. What you can find is Schottky diodes are in most amplifiers for 2 reasons. They're commonly found in switch mode power supplies because they are able to switch at very high frequency. But in areas like in this example here, if you replace the conventional silicon diode for a Schottky diode, what you'll find is that it will generate less electrical noise. Also as well, it has a lower turn-on voltage of 0.3 volts. So the 4 diodes were replaced. And then what the designer is also saying as well is to replace these other 2 diodes here, as highlighted on the extract from the schematic, and to remove them, but now to replace them with 10 ohm resistors with a wattage of 1 watt. And as with more modern components, it's very easy to source a metal film type resistor, which again will generate less electrical noise. What's nice with this amplifier is if you look at the design of it and you look at the multiple protection circuits here, this is kind of unique. You tended to find this type of high-level protection circuits in much more expensive amplifiers. Here we have over temperature detection. We also have, of course, the speaker protection as well, and also the DC offset protection. Very nice design. And when you look at the amplifier in terms of performance, it does deliver a quality sound. So once that was done, and here what I'm showing you is a circle around the brand new Schottky diodes which have been installed. And then here in this photograph, what you can see is the replacement speaker protection relay reference RL1, and what I've done is I've put details of the part number in the description for the video. So again, if you want to do this modification yourself as well as all the other parts, then you can order them. In terms of cost, these were ordered from DigiKey, and in the UK plus shipping the cost for the parts is approximately £37. And then here what we're highlighting is this is D210 and D211, which the designer refers to, and what needed to be replaced, as we said, with a 10 ohm 1 watt resistors. Out of interest, I placed one of the power supply smoothing capacitors onto the ESR meter, and this should be 10,000 microfarad. So although this amplifier of course has been in operation for many years, you can see that this capacitor is still in good condition. The ESR level is very low, 0 ohms, and you can see here that it's not that far away from 10,000 microfarads. Normally for large electrolytics, it's plus or minus 20%, so here well within specification. Here for information as well, all of the other circuit boards were checked, and the reason for that is, as we saw on the main amplifier board, you can get instances where you have dry solder joints, which could be heat related or where you are seeing mechanical stress. So here with the RCA input sockets, it's always beneficial to check all of those, and then also on the tone control boards as well. Now, one of the modifications, which really is a critical modification, is to replace the 4 LEDs within the amplifier. And what the designer is advising is to raise them up from the circuit board as high as you can, so at least 20 millimeters. And on some of these amplifiers, what you'll find here, these fiberglass sleeves are already fitted. I've repaired a lot of these amplifiers over the years, and I have seen very early amplifiers where the LEDs are mounted flush to the board, but they can fail and cause intermittent operation. Brand new LEDs are then fitted. I've also put 2 circles around the preset potentiometers that you see, and these presets are used to adjust the bias for each of the channels. There is no separate preset to adjust, for example, DC offset. And then here we took an extract from the service manual, and what I've done here is multiple things. The first one is that I've drawn green circles around the LEDs, and you can see where they are in the circuit, and commonly with LEDs it's about a 1.2 volt drop across there. And then you can also see the bias trimmer, which we saw a moment ago, and if you're going to be setting up the bias on the amplifier, you need it to be running probably for about 15 to 20 minutes so you get stabilization. And then what you do is you will make the measurement directly across the resistor, and you can make that adjustment until you're reading a value of 12 millivolts plus or minus 1 millivolt. What I've also done is I've drawn a yellow circle around the FET. Now with the FET, again, you can get failures of this component, and typically if you remove it from the circuit and you put it onto a transistor tester, it will just simply indicate that it's a junction, i.e. it will be reading like a diode. If again you had any issue with excessively high DC offset, what you need to be looking at is the long tail pair that you see there at the input stage of the amplifier, and then to replace them. You can also see as well the switching contacts which go out to the speaker terminals, and as we saw previously on the other schematic, there is also a time delay circuit associated with that via a simple RC network which charges up the capacitor and then switches on the transistor, turn the relay on. And the objective there is that when the owner powers up the amplifier, it just makes sure that the connection to the speakers is muted for about 5 seconds, allowing the power supply rail capacitors to charge up so you don't hear that thud through the speakers. And then when the owner depowers the amplifier, then it will de-energize. So if we sort of just step through this, the first thing that I'm doing here is I'm measuring what is the DC offset on the rear terminal. So this is the left channel, and it's very low, so it's only at 4.64 millivolts. So there's no concern there with the input long tail pair, no reason to change either of those transistors. But remember, if you are going to replace them, you need to replace both of them and then use a transistor tester really to get the gain or the HFE so the 2 transistors match. And then if we look at the other channel, now we're looking at the right hand channel, you can see again very low. So this is just minus 5.08 millivolts. So again, no concerns with the input stage of the amplifier. Now on this photograph, what you can see is I've just connected across one of the emitter resistors, and what I'm doing is I'm just measuring the current level and the volt drop across the resistor. And as you can see here that the bias level is quite low. It's only 1.94 millivolts. It's a simple matter then of just adjusting the preset until we read 12 millivolts, and your tolerance is plus or minus 1 millivolt. And if you just let the amplifier stabilize as you make the adjustment, you'll be able to get it pretty much to 12 millivolts. And then here on the next channel, what we're showing you, the same as what we saw before, it's a little bit low, it's down at 1.97 millivolts. Again, we just make the adjustment, and then here we're back up to 12 millivolts. What I also do is I just leave the amplifier running maybe for an extra half an hour, and then I will then come back and I will recheck the measurements, make sure that nothing has drifted, and then make any small adjustments. And then when we look here now from the top of the amplifier, this is with all of the work completed. So all of the dust has been removed. As we said, we've replaced the power cable which comes in, and then we've replaced the LEDs, the 4 LEDs on the circuit board. We've completely reflowed the main circuit board to ensure that all of these dry joints are taken care of. We've replaced the 2 large power supply electrolytic capacitors. The main rectification diodes have been replaced with Schottky Diodes, and then the other smaller 1N, I think they're 4001 diodes, have been replaced by 10 ohm resistors. And then the other work that needed to be carried out was, of course, to check for dry solder joints on the input stage of the amplifier and also the tone control circuits, and then also to clean the switches and the user controls with Deoxit D5, just to make sure that the operation of those switches and potentiometers was noise free and you had the repeatability and reliability. And then here a little bit more of a close-up view. Just for information, the capacitors which are fitted in the power supply are Rubicon, and it is a nice design. I do like working on these amplifiers. And then here we show you all of the different components removed: the original power cable, the speaker protection relay, power supply capacitors, and then the 4 LEDs, 2 smaller diodes, and then the original rectification diodes. And then the only thing that remained was just to put the amplifier onto a full functional test. And if you want to do the work, as I said previously, just check the description and you can see all the individual part numbers in there. So that sort of brings us to the end of this tutorial. If you need any help, guidance or assistance, by all means email Audio Amplifier Servicing at AOL.com, and I'll be more than happy to provide any guidance or support that you may require. So as always, I appreciate you stopping by. Until the next time, cheers and bye-bye.